Good morning, good afternoon, good evening. Today I'll be making this rolling text effect. Unlike simple rotation, rolling physics requires calculation of contact point between geometry and ground as pivot. Though simulation zone is used, the method I'll be showing is very lightweight and simple to use. I'm going to be using simulation zone, repeat zone, and bake, so Blender version 4.1 or higher is required to follow along. Alright, let's get into it. Alright, as soon as we get into Blender, we'll hop right into Geometry Nodes Layout, H select all, X to delete. Shift A mesh plane, and using numpad 7M5, go into top orthographic view. Click on New, delete group input, add a string input instead. We'll type in a capital A and pass it through strings to curve, then out. Alright, so today's effect is going to be a rolling effect. So the difference between rolling and simple rotation is if you have a rotation, you'll have a single axis or single center of rotation, and the mesh is going to rotate around that point, right? However, if you're talking about rolling, you're assuming you have some kind of a ground plane, and there's going to be contact points to that ground plane. For example, for this A, we'll have 4 points, but if you're rolling from right to left, this is going to be the center of rotation, this contact point. So the rotation is going to happen around this point, like so. And for this A, after it rotates or rolls to this position, the center of rotation or the contact point is going to change to this point, and it's going to start rotating from here, like so. Right? So it's a bit more complicated than simple rotation algorithm. So, well, let's get into it. Alright, so the first thing I'll do is actually just fill the curve and get geometry. It doesn't matter whether it's triangle or n-gon, but I'll just go with n-gon. Next, I'll be looking for the contact points, as I mentioned. So first, let's realize instance, and also bring out a bounding box. And from the bounding box min, I'm going to separate XYZ. Also add a position node and get a separate XYZ from position node as well. Okay. So what I'm looking for is a point where all the minimum Y matches the position Y. So I'm going to pull out a compare equals and also connect this position Y into B as well. Right? So if I look through the viewer, there's going to be 4 points. As you can see in the spreadsheet, there's 4 points, which are 1, 2, 3, 4, which are candidates to be the next center of rotation. So what I'm going to do is, as I said, I want to get the furthest left point within these 4. So I'm going to draw a line out of here and get an attribute statistics node. Okay. I'm going to plug the result of equals to selection and also separate XYZ X into attribute to here. So what I'm going to get out of here, the minimum of attribute statistic is going to be this point. Okay. So I'm just going to combine XYZ and plug it into X. And also from the bounding box minimum Y, I'm going to bring the line over here and connect it to Y. Alright, so now that's done, we now know where the next center of rotation is going to be. Okay, so I'm going to actually move this over here. From the line of fill curve, I'm gonna add a rotate to instance, plug it in here, and plug this into pivot point, and clear the checkbox on local space, right? So if I were to set some value into this Z rotation, you can see that A is rotating, but since it's well, A, you can't really tell if it's just rotating from origin. So I'm just gonna change the letter to C. The contact point for C should be somewhere around here, so the rotation should happen around there. And yep, it's happening there, so it looks cool. Alright. Next, what I'm gonna do is I'm just gonna plug this into simulation zone, since this algorithm requires this center, contact point to be updated every single frame. So I'm gonna use the simulation zone. So I'm just gonna make a space like this, and add a simulation zone from here to here. I'm gonna reconnect from here to here, now there, and here, and here. Okay. So it's gonna look like this. I'm gonna bring it down. So fill curve, simulation, realize instance, rotate instance, simulation output, something like that. So if I were to plug in a value into rotate instance Z, say 5, and I'll go back to the first frame and animate, you can see now it's rotating, right? Well, rolling. So I'm just gonna change it to A to show you how it works with A. Right, so it's rolling, rolling, rolling. Yeah, right. But as you can see, this A position is going lower and lower into Y. The reason for it is that there's going to be an overshoot every single frame, and that gets carried over to the next frame, which gets carried over, so it's going to go lower in Y axis. So I'm actually going to make adjustment to it, so it goes back to the X axis line. So I'm going to make a space between rotate instance and simulation output. I'm going to realize the instance and grab a bounding box, and from bounding box min I'm going to separate x, y, z, and from y I'm just going to do a multiply and multiply by -1. Then I'm going to combine x, y, z and plug it into y, and also use a translate instance between rotate and simulation, and plug the result of this combine into translation, and uncheck the local space as well. Okay. So now if I were to run the animation, you can see the A stays above the x-axis red line. Cool. Alright, so we've successfully managed to roll an A. So what if we plug in a little bit more letters, right? So if I put AB in here and try to roll it, well, it actually works, right? So it's kind of cool how the rolling conforms to the curve of B, and yeah, it looks pretty cool, but I'm pretty sure this is not what we want to do, right? We want these rolling to happen independently, right? So we'll work on that next. Okay, so what I'm going to do is create a little bit more space between here and yeah, that part's fine. Okay, now I'll just go back to frame 1. What I'm going to do is actually perform these operations one by one, right? So even though there's A and B, I just want to work on A. So what I'm going to do is use a separate geometry, change points to instance, connect it up like so, and from selection I'm going to use a compare equals and connect A to index, right? From selection, I'm gonna connect it to realize instance right here. Okay. All right, and I'm just gonna bring this guy down a little bit more, and I'm gonna connect the result of equals to selection of rotate instance right there. Reroute and bring it down. And also I'm going to connect the same line to translate instance selection right there. Okay. So now if I were to run the animation, you can see A is rolling independently and B is not being updated. This is actually what I want, but I just have to show you that right now this bounding box is covering both A and B, and this is not right. So what I'm gonna do is actually split it up like that and add another separate geometry before realize instance right here. Change it to instance and connect it up like so. Okay. So now if I take a look at the bounding box, it's only covering A, so that's actually making adjustments or making corrections based on one letter at a time. So, right, great. So now A is working independently. So now I can use repeat zone to repeat everything for all the letters. Okay. So I'm just gonna do a reroute here, and I'm gonna make some space here. I'm gonna make some more space right here as well, and add a repeat zone right here. Okay. As soon as I add a repeat zone, I'm just gonna add a iterator. So I'm gonna add a mask node, connect empty socket to the top, add 1, and connect the output to repeat output. Okay. Now I'm gonna bring the output part all the way to the right between translate and simulation, and gonna reconnect. Actually, I'm also gonna change the name to iterator and set the type as well. You don't have to do it, but I just want to keep it clean. So, right, so I'm gonna reconnect. Let's see, it's in the right place. So go back to the simulation geometry, connect it up like that, and from repeat, connect it to wherever this reroute point is, and translate instance to geometry and repeat output to simulation. Okay, it's gonna look like that, and I'm gonna bring it down. Here we go. Cool. As for number of iterations, I'm gonna pull out a line and get a domain size, get instance, which is a number of letters, instant counts to here. And also for the iterator we just made, we're going to plug it right into compare equals B right there. Okay. I'm going to bring it up, and is everything connected? Yes. Let's go okay. Okay, so now if I were to go back to frame 1 and run the animation, you can see both A and B are rolling independently, and it's kind of looking nice, right? But in terms of, well, the rolling mechanics is pretty much complete, right? So this is how rolling is supposed to work, and it's working perfectly. However, in terms of the animation, there is a huge problem. So I'm gonna change the string context to well, rolling text, and let's see this animate, right? Okay, it's rolling, but well, you probably can see the problem, right? Well, you can't read this. You know, if it's a text animation, I'm assuming that you're planning to let the viewers read what's in there, but you can't really read what's going on right there, right? So I guess there's a lot of ways to fix this, but there is a particular way I like to fix it, and that's by basically setting one point to let the viewers read what's going on. Okay, so before we do that, I just want to make a little preparation. So I'm just gonna select everything within the simulation node right here and make it into a node group by Control G. Okay, and also I'm gonna duplicate this group input and bring it all the way to here before the rotate instance. I'm gonna grab a combine XYZ out of rotation, and from Z I'm gonna pull out a 2 radians and connect it up to an empty socket in group input. Okay, so this is just for preparation, and I'm gonna name this rolling text node group. Right, reorganize so there's not too much space. Okay, right. So what I'm gonna be doing right now is basically adjusting where everyone's gonna read this text. So say for example, if I were to run this animation, there are going to be points that this rotation, everyone's going to be standing up. Every letter is going to be standing up. And for all these points, what I'm going to do is I'm going to shift everything initially to the right. So there is going to, at this point, everything's going to line up perfectly. So it's kind of hard to explain, but I'll just show how it's going to go. So I'm going to actually use 144 second point right here. This is the point that all the letters are standing up. So what I'm gonna do is from here I'm gonna get a bake node and plug it in here. If you know how to use bake, you'll know that you have to have this blend file saved. So I'm just gonna save this blend file, call it whatever you want. And at this point, at this 144 frame mark, I'm just gonna bake, right? So you can see that baked frame is 144. And now, because I know there's this much offset between these texts, I'm just gonna offset everything initially by how much we're off by. Okay, so from the bake, I'm gonna grab a sample index and change the float to vector, point to instance, and plug in position to value and index into index. Okay, so this is going to be the offsetted points at 144 frame mark, and the original position is here, right? So I'm going to get the original position and use a vector mask to subtract the 144th mark, like so. Then I'm going to use a translate instance and plug this result of subtract into translation and click off local space. Okay. Alright, so if I were to, well, at frame 1 you can see that everything's out of place, but if I were to run the animation, actually before that I need to duplicate this rolling text and bring it over here. Okay. Right, so going back, if I go back to frame 1 and run the animation, you can see everything's rolling, but at 144 mark, 144 frame, you can see everything's aligned, right? So going back to frame 1, you can see everything's out of place, but right here, right, this is where everything lines up. And if you keep on going with the animation, it's gonna keep rolling off, right? So basically I wanna hold it at 144 mark for a little bit, then let the animation resume. Okay. So the first thing I'm gonna do is back at frame 1, I'm gonna keyframe this rolling text value, which is a degrees, to 10 and keyframe it. Going up to 144, I'm just gonna change the value to 0 and keyframe. Move it a little bit forward and keyframe at 0 again, and move it all the way to the end and put whatever value you want and keyframe it like so. Okay. So if I were to run the animation, you can see everything's rolling, and at 144 it stops, and you can read it and it goes off rolling again. Okay. Alright. So though it's always going to be out of order, out of sequence, it's still going to be readable, and yeah, it kind of looks comical and fun, right? Right, I'm not going to be going over any materials, so let's go back and summarize what we just made. So since we're using node group, the top layer looks kind of empty, but this is where I'm adjusting the animation so you can read it. Going into the rolling text node group, this is basically what we did. This is the rolling mechanics. Right, going from left to right. Check your connections if things are not working, but it's a pretty simple node group. Just make sure the repeat and simulation zones are working correctly. So yeah, and this is basically it. Alright, so I think this effect is pretty cool. I like how I kind of came up with it, but yeah, it looks like something, the end credits of animation movie, or maybe something like Pixar does with their staff credits and things like that. It's kind of cool effect, right? So thank you for watching, and see you next time.